Welcome to the John Myer podcast. Today we're talking with Micah Frederick, Cloud Ops Lead Architect at PTP. Our topic today, high performance clustering. Please join me in welcoming Micah to the show. Micah, thank you so much for joining me.
Thank you. It's been a lot of fun so far in this kind of industry.
Well, you know what, Micah, let's jump into that because you said it's fun so far with this industry. And I want to dive into your background because I feel you have a well-diverse background between DevOps, automation, compliance, security, and now high-performance computing. How the heck did you get all this diverse background? And now why HPC?
I started doing networking mostly, network operations center, went into network engineering, routing, switching, all that fun stuff. And I started to find that there was a big need in the companies I was working for doing automation and networking. So I started building up all of my automation skills, started getting into network automation. I kind of blended over to us getting into compliance, starting to automate compliance and security stuff. So from there, I was at that point pretty versed in the whole DevOps, architectures, doing web development, doing back-end programming, all these kinds of stuff. Started filling a niche of just, we have a problem, we don't know how to fix it. And I just come up with some weird solution, which is not too dissimilar from some of the HPC stuff. But that transition, when I joined PTP, we really started getting into cloud stuff. So I really adopted learning all the cloud, put all my DevOps information knowledge into that cloud, just kind of a natural fit. Those kind of dovetailed pretty nicely. Doing everything as code, infrastructure as code, starting to really create that kind of automation worked really well in the cloud AWS world. So from there, we started getting some HPC customers, and we're just like, well, what do we do with them? And I'm like, I don't know, figure it out. This is where we got. And so I started really delving into the world of HPC, learning all the pipelines, the technology, the lingo. I've now learned way more about data scientists and research than I would like to know. And I still don't know almost anything about it.
I can see the correlation between your networking, right? All right. Now you did automation, and then DevOps has automation built into it. Your security, you're building automation into it. And now HPC, you're building automation into the pipelines. Before we dive into it a little bit more, can you explain to everybody really what is HPC and how it relates to PTP?
So HPC is just high performance clustering. So it's basically the ability to spin up large compute nodes. And usually they're not singular nodes. They tend to be clusters of hundreds, potentially thousands of CPUs or computers that are all running, kind of in orchestration and coordination with each other to, produce some kind of data or analyze data to do whatever job you've scripted it to do. So how PTP kind of works into this is helping companies. They know they want to leverage that kind of scale and that size, but they don't know how to get into it. So we kind of help them bridge that gap from, I've got these couple things that I run on my computer. How do we turn that into a large scale production workload?
Okay, you just said high performance clustering. What's the difference between high performance clustering and computing?
Well, mostly it just deals with this number of simultaneous computers. So you can either do one job on one very, very big computer, but you will run into a just limitation of the amount of CPUs or whatever can be put into a singular physical server. There's just limits. When you get into clustering, you're basically saying, I want to take potentially hundreds of servers, coordinate them all together, and I can run a job that I can split over all of these different compute nodes, and then collect that information back together to get one finished product. So it's mostly just a scalability thing, and the ability to, really precisely use the amount of computing power that you need.
So, Micah, how does a customer really define and know that they need PTP's help? Do they one day wake up and say, you know what? My current HPC, my processing for my batch, for my bioinformatic customer, I really need to improve performance, right? It's taking me 6 days to process this. I want to get it down. How do they even know they can get it down? Or how do they engage with PTP?
So it usually does end up to be something like that. They've worked on a pipeline or they've worked on a series of steps. Like I run these 6 tools on this sampling data, and I get an output that I can then analyze. They've kind of built that. They've done it on their little laptop or they've done it on a server on their like on premise, and they're going, well, this takes hours, it takes days. I have to switch each step, and they're kind of going, I need to be able to do this better, faster, more efficient. So you've got that comes from that side. A lot of them, these are all, PhDs. So these are all data analysts, like really smart scientists, people coming from research, universities and stuff. Those research universities have high performance clustering that are available to them with all these tools installed. And they've been used to, in their kind of research academia world, to just being able to run things. Well, now they go into a private sector and a company. That company doesn't have that. Like they're not MIT. They don't have, they haven't set aside tens of millions of dollars to build, big server infrastructures and make that presentable to everyone. So now they're trying to replicate how to do things that they could do in academia now into the more of the private sector. And so they reach out to us to kind of help that because they know kind of their end goal. They know where they want to go, but they're not infrastructure people and they don't necessarily know all the cloud stuff. So they just know how it was done for them, and they want to be able to utilize some of that functions.
So, Micah, now I'm seeing the correlation where they were once doing it or trying to achieve it, or even it's a net new customer saying, I want to do X, Y, and Z. I want to process the data. I don't want to worry about the infrastructure. And by the way, cost is a huge concern for me. So, Micah, they come to PTP and say, hey, listen, I used to be able to do this in one day. Now I am in a private one and it's taken me 7 days. Walk me through the steps. And do you have a specific customer example you can share with us on how you engaged with them? And then what was the ultimate end goal?
So, yeah, I mean, a lot of them, that's just kind of how it comes in. So they would start to do that and they'll reach out because they may have an idea of what they want to build. So sometimes we get very specific, like I would like to build this kind of a Slurm cluster. They have a very specific, technology base they want to build. Come with much more of a, we know we need to build this. We don't really have a preset idea about how that needs to get done, and we can work with them to build something potentially very different from what they used in the academic world. What's the academic world? They have big physical clusters. So they're on site, they're big clusters they can use. We're now using cloud infrastructure. So we're leveraging potentially clusters that could be hundreds of thousands of times bigger than the ones they use, but they're different. Their access different, the technology is different. So like AWS gives us much more ability to use like ephemeral resources so that we aren't paying for large clusters to stay up when they're not being used. We can just run them, as we need them. So for each of those clients, we tend to get their requirements, we get what they're looking for, and then we start helping them break that down kind of into the pieces that would be required. Like what's the software that needs to run? How do we run that software? What's the best fit for the resources? And a lot of times we take them sometimes from their original thought into a completely different, kind of vein to say, we can do what you want. We can just do it cheaper and we can do it faster over here. We can kind of future proof you a little bit from your original idea.
So, Micah, I want to talk about cost in a couple of minutes, but I want to go to Vaxart and back to the process. This was a net new. They had an idea of what they wanted to achieve, and they had an idea of what the end result potentially could be.
Yeah, so what they're mostly doing is they'll know that they have X amount of sampling data, they have their own lab, they're producing, this raw data from samples, and they need to evaluate it. They need to analyze it, they need to splice it, slice it, dice it, whatever they want to do. It's kind of like a kitchen utensil, I guess. Um, and I don't know all of those tools they do. I've started to get more familiar, but they'll start just whipping out terms, and I'm like, yeah, I don't really know what you're actually trying to do to that DNA sequence. That doesn't make any sense to me. But we'll help them go. You have raw data. These are tool sets you want to be able to build, like tools that you want to be able to use to evaluate the data, and you're trying to get into some kind of end state that they can then do more data analytics at, visualizations, all that kinds of stuff. So we'll take that and we'll start kind of breaking that process apart. So like we'll take all those tools, we'll start building those tool sets, like we'll get them installed into containers, whether it's Docker, Conda, any kind of containerized methodology, so we can kind of self-contain those tools, kind of control their prerequisites, control their dependencies. We start creating them a library of these tools that they can use. We start building a landing zone for all that incoming data, so a big bucket where they can stick raw data, and then big buckets where finished data can go. And then the bigger thing we've helped a lot of them with is then adopting an actual pipeline technology. So like the big one in the industry at the moment is Nextflow. So that's the one we're really working with. And that just helps automate those stepped processes of doing all of those tasks. So instead of them going, oh, I have data, I'm going to run this one job, and then it gets output. And then they go, oh, then I want to run these 3 jobs on that output, and then get what that is. And then they're going to run 2 other jobs. Instead of them kind of doing all that, we start building these like pipelines so that we can just say, we just put input into one side of this pipeline. It's going to run this task, and then it's going to run these 3 tasks. Then it's going to run these 2 tasks. Then it's going to combine everything and run these other 5 tasks. And then we'll combine all the data, we'll reevaluate it, I'll stick it in an output spot somewhere.
Nice. So it's an automated workflow utilizing step functions, because there's also AWS step functions, but Nextflow, what you're utilizing is to automate the process, because the person that's sitting there through the company is not necessarily the one that you want for managing the infrastructure. They should be worried about the output and analyzing the samples. Your job is to really get this data processed as quickly as possible into an end result for them to utilize and evaluate.
Yeah, they went to a lot of schooling to, about analyzing DNA and RNA sequencing data. They don't need to be focused on, why am I getting this compiling error when I install this software? Why is this library dependency not working? Why is, oh, I got the data. Let me go type in to click the next job. We want them focused on what they're really good at. We're really good at doing this part, the infrastructure, building that automation, building that tool set, getting that to flow nice and seamlessly. So that way they can focus on what they do well, what really drives their business, makes them money, and leads to whatever next discovery they're looking for.
What I imagine that you do is you take the output, whether it's in any type of format. I'm just going to use CSV because it's the most common one. And you take this output and you parse it to exactly what it needs to for the current input that you're going to send it to. And that's going to evaluate it, thus providing an additional output. And it's going to rinse and repeat throughout the cycle until it finalizes the compiling of the data into, so that the data scientists can analyze it. Is that pretty much what sums it up on how you're doing the process, or is there more involved?
Yeah, I mean, that's a lot of it. What they usually start with is more like DNA or RNA sequenced pairs. So there's these giant files of like sample data, which look like nothing to me. But yes, it is slicing that, stripping it down. They're looking for very specific things. They're trying to like isolate parts of that strand or whatever they're looking for, getting that into an output at the end that they can visualize, that can be like graphed, that can be looked at, so that they can compare results across hundreds of samples, looking for like similarities, things that match up, things that don't. It varies widely, and this is just depending on what company it is and what kind of research they're doing and what they're trying to look at.
Micah, is PTP able to analyze and realize the individual steps and functions that can be performed in parallel or sequence in order to improve the processing cost and efficiency?
So yeah, we a lot of times do help with that. So a lot of times we've had customers that have come with their own pipelines. They said, I've got this all figured out. I get one sample out here, and this is my end sample, and I've wrote this next flow pipeline, and it's 42 steps long, and it does all this data, and it collects all of these outputs that we can analyze. And where I go, that's great, looks good. And then I take it and we'll start helping them put it into the cloud, get into AWS. But part of that, we'll look at that pipeline and go, you know, steps like 16 through 25 can all happen at the same time. They don't need to be in series. So let's move that around. And then, oh, well, these steps can actually parallelize for this way and this way. And then we start shrinking that pipeline of down, that they go, hey, we got an automated pipeline. It's automated. They don't have to do anything, but it's taking 24 hours or 2 days to finish it all. I can go, we can do that in like 4 hours. Like if we rework the system, we can do that in 4 hours. You'll use the same amount of compute. Would you rather do it in 4 hours, or would you rather do it in 3 days?
So the improved efficiency is going from like 50 to 75% for you're sitting down and analyzing their current or existing pipeline that they set up. And it's really meant about educating your customers around the efficiency of doing the automation. Granted, you have a pipeline in place. You're not trying to tell them that it's wrong. You're just saying we can improve this efficiency so you can get the data and you can do your job instead of waiting for this to complete. Because I imagine the 3 days of it processed, and they're like, yeah, I'm gonna take a vacation. Now it's like 4 hours. Oh man, I can process more stuff.
It's just a long lunch at that point. Um, so yeah, I mean, it works in many different ways. Sometimes they have a pretty good pipeline. They have a pipeline that's pretty efficient, but they may be using an older clustering technology, and we can introduce them to a newer clustering technology to make better use of cloud resources, so we make it more efficient on that side. So it just depends on the customer. So they're all a little bit different. So we usually try to sit down in that same way of, what are you trying to do? What kind of data are you starting with? Where are you trying to get it? How can we build these things? And then helping them get them into like the most efficient model for, whatever their particular business is.
Mike, I'd like to talk about cost a little bit because cost is a huge role in doing high performance clustering, right? I can run this huge cluster and it could cost me a lot of money, or I can run this small cluster for a longer time and it costs me a lot more money. How are you aware of the resources that need to be allocated for this processing or the processing that needs to happen? How are you deciding what's more efficient?
So usually we try to do it, a lot of times we'll do some unit testing pipelines. So we'll build some different pipelines, um, utilizing different resource types, like even different CPU or GPU architectures behind the scenes, different amounts of memory and CPU, try to get an idea of how much each step potentially can cost. Um, Sometimes that involves running those jobs on an isolated server, just running it, being able to track the metrics on that server, look at kind of your memory and CPU usage, getting an idea on how much those things take, and then usually trying to get them into a technology that leaves those servers running for the least amount of time. So in general, almost always, it is more efficient to spin up some bigger servers for shorter periods of time that you can cram multiple jobs onto and get them all done and just be finished. And then there are times it might be smaller servers, but you have a push and pull between the cost efficiency of the compute running versus the cost efficiency of people waiting to do things. So usually try to push that things get done quickly, because if you set up the right kind of cluster using the right kind of technology, those clusters spin up, the pipelines spin up, it runs all this compute, and everything shuts down. There's nothing left running. So when it's not running actively a job, it costs you zero, compute, and you're only ever paying when you're processing. So in that kind of model, you might as well process as fast as you really can, get the data sitting there, and then it can just, it may not run for days, it may not run for weeks. Just depends how they get data in. Sometimes it comes in big batches. You've got hundreds and hundreds of samples that you're running through. May go for a week or several days where it's just computing all kinds of data and then nothing for a month.
Okay, you said something interesting where it might be more efficient to utilize a huge high performance cluster, big CPUs, massive amounts for a short amount of time, rather than the person who is waiting for this to process to sit around and waste their time. And it's actually a unique perspective, because if you can process this in maybe 3 to 4 hours or a number of jobs for a number of people, now they're not sitting and waiting, and you gave them their data, you shut down this cluster. That's a good way to look at it.
Yeah, you can spend, arbitrarily, let's say you spent $1,000 to run a cluster for 3 days, whatever it is, and you're going to run this job, and it's going to take 3 days, and it's going to take $1,000. Well, there's all the technology out there in the cloud, especially. I can take that same $1,000, I can spend it all in the span of like 6 hours and just be done. So there's usually just not a reason to let them run on small nodes for very long periods of time when you could run on bigger nodes faster, just a bigger cluster with more parallelism, and get things done. And then the data is now available. So now the scientists and the people at the company, they're not waiting for data to do their job. There's always like new stuff ready for them to process. And they may easily start processing, and we've had this happen. They'll process some stuff and they go, we actually are missing a piece of information that we need. Can we add this task to the pipeline? And we can go, okay, yes. And then we can create a second pipeline and reevaluate all that process data for this additional piece. So they're not waiting. It's not like they've, oh, well, we waited weeks to finally find out that we forgot something, or this sample's just bad. Like sometimes data is just bad. It just doesn't work for what they need. So you might as well get it all processed so they can quickly go, yeah, this is all bad. Like, those can just be ruled out. Let's get more data in. Let's get more samples. Let's keep going with this processing. There are some places where using smaller nodes can be advantageous. You can kind of take use of some of AWS's spot pricing to kind of really pick and choose at instances you want, to kind of really maximize cost efficiency. And in those cases, you're running very specific types of jobs that do a lot of highly checkpointed jobs that can withstand interruption and restarting constantly. But in those worlds, you can potentially play a game that if you're like, well, I don't really need the data for a week or two, that you're like, I can just let this run and I'll just pick and choose when like spot instances are really cheap and run it. And once the price goes up to a certain point, I can be like, I'm out. I'll just wait. And then I'll keep going. And then I'll wait and I'll keep going. So those are kind of more niche cases. So you have to evaluate kind of what their needs are and what kind of jobs they're running.
I like how PTP is taking a customer approach, right? A detailed approach to these jobs, not only the cost, running things in parallel, or how they can minimize some of the tasks that are involved, and taking the infrastructure management away from the customer so they can focus on the actual job of analyzing the data. They're really taking all customer aspects into consideration. Who's building some of this automation around it? Are you jumping in and building like, okay, I need to shut down this instance when not in use and we're going to save some cost, or I need to build a script to parse this amount of data? How is that actually defined?
So normally we use a lot of like tools that are kind of built in, either to AWS or with Nextflow. We like to use a lot of AWS Batch in conjunction with Nextflow, so jobs are run as needed. Basically, we're not even really desperately worried about the infrastructure where we've got a job running. Nextflow's kick this job off. Once that job finishes, those compute nodes just go away. We just don't even ever worry about keeping anything running. Things only exist for the length of time that we need for that job to process. So that we do that. I mean, that's kind of an easy way for the pipeline to work. We've got some other issues with some analyst boxes and stuff when they want to analyze data posts that we kind of can play around with some CloudWatch, logs and like alarms to look for inactivity on boxes, automatically terminate those, kind of stop that data. Like those are a little more niche case. That's kind of more after the fact of the HPC. But most of the stuff we do with the HPC is all very ephemeral.
So, Micah, you mentioned AWS, you mentioned internal. Are you seeing a lot of customers doing private, public, or a hybrid type of method?
There are some. So I would say a number of them do a form of hybrid. Just maybe not exactly what you're thinking, hybrid. So we do have some customers that want to have some on-prem HPC. They have some on-prem servers. Some of it's with having big like GPU clusters, the availability of GPUs in clouds, availability of GPUs anywhere has been a little questionable recently. I think, maybe the Bitcoin plummeting might help that. But so they'll build these big GPU clusters that they can use on-prem, but then they want to be able to like push some jobs into the cloud, run some locally. So we've got some of that. And Nextflow has some ability even inside of its pipeline to control where the process gets sent. So it can send it locally, it can send it across the network and, let that run in the cloud. The bigger thing we really get into, it's kind of more hybrids, is companies that have like labs. So they have wet labs, they're doing sampling data, they have big samplers. Those data, that all gets run and gets stuck onto like network storage on their local on-prem that needs to get moved into the cloud then for processing. So we help build some of that for them to kind of give them an automated, like a storage gateway that AWS puts out there so that they can run data from their sampler that gets stuck onto the storage gateway that automatically shows up in S3 in the cloud. And then we can build automation so that as soon as that data arrives in the cloud, we automatically kick it through these pipelines. So they don't even have to initiate them. It is just we ran some labs, we ran some experiments in the lab, we got the sampling data, we they finished up at 5 in the afternoon. They come back in the next morning. Oh, that sample that already went up into the cloud. It's already been processed. It's come back. Um, that's just all done, nice and
And
tidy.
I enjoy the automation part because you actually just indicated it's 5 o'clock and a lot of people are knocking off for the day, right? And they're like, oh, I'll start processing this tomorrow. Now they've just lost like 12 plus hours of moving and managing the data. Where if the data is sitting on a storage like a storage gateway, then it's up to AWS, and once it detects that there's new content that's been uploaded, it's going to start processing that, utilizing the batch. And when they walk in the next morning, now they can start analyzing the samples and doing more samples off of that and reprocessing the data.
Yep. Um, it the cloud never sleeps basically. So we automate this. We put in all these pipelines. These things can run at any time of the day, any hours. So sometimes it's an issue of they're all doing stuff and it gets to the end of the day. They finished their experiments. We can run overnight. That can all be done. There's another element where some of these companies are global. I mean, they have scientists all across the globe. You'll have some guy in Germany working. He can finish up, put data in there. It can be processing. So by the time, people in the US get to it several hours later, it's already gone through certain steps. By the time it gets to like people in China, it's had time to process. So you're not stuck on waiting for some people's schedules, based on your time zones either.
I imagine you're taking that into consideration when building the pipeline of the different time zones, thinking, okay, over in the UK, this needs to process in 3 hours to be available for those in the US. Now you tried to actually improve your processing and your pipeline to be more efficient and available for those when they come into work, so they're not sitting around waiting for this data.
Yeah, so we can optimize that, try to get that shrunk down. You can start figuring out like, oh, well, the person in England or in the United States, whatever, they only really need this subset of this information so they can continue. So we can front load that into a pipeline. So when it starts, that gets processed first. It gets automatically, as these pipelines run, outputs from different steps get made available to the end users as they go. So you can make sure that that data gets available while the rest of the pipeline kicks off. You can have branching pipelines or simultaneously running. That basically we have a giant pipeline that runs data end to end. Once it gets to step 3, it outputs this data in this directory, at which point you can have an automation pick it up and say, well, now I take that output and I run a whole different pipeline. Like that may be completely independent of this, that does some different kind of analysis that transforms that data in different ways for a different part of the company or different end user. So you can kind of line those up so that you can kind of best utilize that time away from the office that people. So when they're not there, or, that it just keeps running. So when they are in the office, they're not waiting, for data. And a lot of this gets into that point from earlier of, why would you necessarily want to have a pipeline that runs for 3 or 7 days when you can make it run for hours? Like just run hundreds of things right off the bat. Just keep them constantly running. And then you just don't even have to worry about this as much because it's like everyone has such a backlog of stuff to start working on that there's not a hyper concern of, oh, I got to wait for this to finish, because you're like, well, we already finished it for 500 samples. You've got some stuff to crunch through for a while.
Oh, nice. I like how PTP is analyzing all aspects and handling all variations of the pipeline from beginning to end and automation. I have about 2 more questions for you before we wrap things up. Okay, you're handling everything for this pipeline, but what if I want to learn as a customer to handle this pipeline and be able to do some of the tasks myself? Or do you help and educate the customer saying, hey, listen, if you want this data, you want to move out, you want to manage this type of a pipeline, here's how you do it? Or do you guys just want to, own the whole entire process?
No, on most of their customers, a lot of them get involved in writing parts of the pipeline. So we usually get those pipelines up into either using native tools like AWS's code commit, where we can put it there, or some of them have it like Bitbucket or GitHub, the more obvious one for a lot of people. It's kind of a common code repository, so we can all kind of work on it, and it lets us kind of work with them to do things. So we'll get questions. Hey, I would like to add this. Can you show me, like, how would I need to do this? And sometimes it's, well, I'll kind of show you the example and I'll put it in there. Like, this is kind of how you would need to phrase it. Here's your inputs, here's outputs. And then they can go in and go, oh, well, these are the actual commands. These are all the flags, and then sometimes I'm like, I don't know what the outputs are. So you're going to have to you put that in there. I'll kind of help you with the framework of how it goes, and then you decide what the outputs were from that task and what inputs you need, and then we can do some testing. So sometimes I can just test locally, find out it didn't work, works, didn't works, syntax errors, whatever, and then we'll work with them. So if they really want to get into it, we're perfectly fine with letting them kind of get in there and start managing their own pipelines. It makes it, easier at the end of the day sometimes, because they don't always have to wait for us if they need to make a change. Like, oh, we need to change the flag on this one command because we need, like, it's not the right, like, it's not the right options, or we need to add an option. I think just go in there, change it, push it out. All right, pipeline keeps running. Um, And sometimes, like I said, they'll need to run subsets of pipelines. So it's really easy to, like, we'll just take a section of this, create a new pipeline, rerun parts of old data or rerun data. So yeah, we have plenty of them that'll help build their own pipelines, and they are really interested in how that works, because it, kind of helps them as they go forward, because it gets them ideas like, oh, well, could we do this also? Yeah, start sticking that in there. We'll put that in, and they'll ask us for help, or they might have a pipeline completely finished and they're like, we need to automate this now. Like, can you help us hook this into the data so that it automatically runs and processes?
Nice. So, Micah, what about the security of all this data? How are you aware of or handling the data, whether it's in transit or at rest? Because there's always that concern that even though these are samples, people with PHP needs to understand and use and analyze them or can read them. But how are you handling the security of this data?
So we monitor all that, and it's all kind of built according to best practices as we set these up. So we like to stick data in S3 buckets. That's where we start and stop. Those things are all encrypted. We keep them all at rest, encrypted at rest. When the next flow pipelines and these Docker jobs, run tasks, all that data is moved across S3, across like secure tunnels, either HTTPS or across S3's kind of internal gateways. Is moved in those buckets. For the most of these pipelines, they have no need to reach the internet, so they're all run inside of private subnets. So none of these boxes actually have any access to the external world, so they can't get out. Nothing can get in. There's no public IPs that even exist on them. We pretty much tend to isolate all of the HPC cluster environment anyway. So the only thing running inside of those VPCs is this HPC stuff. So there aren't other computers or boxes or servers from that company that even exist in that same space. So there's no ability for data to leak sideways either. And the biggest thing for it is they're all ephemeral. We just don't leave servers up. So the server launches, it runs, it shuts down, everything gets wiped off of it. It doesn't exist anymore. And quite frankly, you don't get hacked. Servers like that don't get hacked in a matter of hours. That's just not kind of how that works. And there are no usernames or anything on this. So social engineering doesn't really get you into this environment either. So we keep it pretty well locked down. And and then we'll work with the end customer to help them understand how to protect data coming into the environment and protecting data leaving the environment, because there's a point where it passes outside of our control. Um, so if they take data out of S3 and start sending it wherever, I can't do anything about that except, kind of explain to them what the risks are and what they're trying to do.
Security at every turn, plus educating your customers on security awareness and what they're doing and how they're analyzing the data. Real quick, Mike, I know I said two questions, but I have one for you. I'm sure you've run into resource limits on a lot of these HPCs and environments, not only like AWS. There's hard and soft limits within the environment, but also even in the physical or private data centers. How are you handling resource limits? Are you aware of them, monitoring in place?
Yeah, we look at them, and you certainly can get some of these pipelines that'll run into like the thresholds of what they're allowed to do at a company. Some of that gets into prioritization, helping them prioritize data, prioritize pipelines that need run over other ones. Batch has built-in ways to prioritize different pipelines, so you can prioritize what gets accesses to resources over other things. Kind of lets you, kind of scope that out to say some of these big long-running ones, they might get shifted down so that we can always run quickly available things. But you can always run into a point where you've run into this, limit of what AWS resources are even available. So in those, you just have to start working with them to help understand, how many tasks need done, what tasks need done, what are you actually looking at an endpoint? Is there data in here that we don't need to save, that we don't need to process, that we don't need to copy? And these things can shorten the length of the time that it takes to do this. Some of it is, well, if we run out of resources in this region, this is all basically code. We can take it. I can spin up a pipeline in this region. I can spin up a pipeline in Europe. I can spin it up over here. I can run them in multiple regions all at the same time, all over the place. So, sometimes it is just kind of moving that data around, dispersing it so that you're getting access to a wider amount of resources. But a lot of times there's just a better way to do some stuff. So sometimes it's helping them understand the software they're running, the options that are available to that software, like, how many threads can we use? Can we control that threads to make it more efficient? Maybe we put different options on to limit the scope of what we're looking at. Can we put tools in a different order to make one go faster? Can we, instead of doing this huge processing on a full sample, can we first run that full sample through a couple smaller tools that'll like splice out the important bits that they're looking for and then take that data and then process it, as opposed to looking at larger fully sample sets. So that's kind of a game you're always going to play. There's a little bit of a whack-a-mole kind of aspect in that there's always something that kind of can happen. So we just kind of work with him to monitor those resources, to monitor what's being used, to make sure we're using stuff efficiently, to kind of look at trends. Are we using more CPU than we used to, or are we ramping up? Are we ramping down? How can we tighten that down? And we just kind of have to take that as it comes and kind of help work with them on it.
Nice. I like how you're analyzing all aspects of the environment. And I like that you mentioned utilizing different regions. You're like, well, I may have a limit in this region, but now I can spin it up in all these other regions and handle the data at the same time. Micah, thank you so much for joining me. This has been a very interesting conversation.
Thank you. It's been fun.
I want to thank you, Micah, for joining the show. I really appreciate it. Everybody, Micah Frederick, Cloud Ops Lead Architect at PTP. My name's John Myer. Don't forget to hit that like, subscribe, and notify, because guess what? We're out of here.
See ya.